Hi, this is the third update for the PCB Mill. I'll continue designing it. First, I increased the frame size so the Y-axis motor doesn't stick out. And then I tried rotating the guide block plates, but mounting holes overlap with the blocks, so I'll bring it back the way it was. My initial idea was to have this front door like a hood that can lift up for opening. One of the reasons for the hood that it's nice when it's on top so it doesn't get in the way. And since I wanted to reinforce the side C-beam that holds gantry, these extrusions will be on the angle, so the hood could follow the line. But once I mounted the spindle, I realized that the machine needs to be around 70 centimeters tall in order to have enough room so the power cable doesn't have to bend too much when the Z-axis of spindle goes all the way to the top. So if the hood is the size of a full front, once it's open it would be double in height, so it would be around 1.40 meters. So if this machine is on a table, it just gets too tall, so I had to redo the design with the regular opening door. Front door is held by 3 hinges and plexiglass covers the door and the sides of the enclosure. On the back and on the top it will be white acrylic. Most likely all sheets will be 3mm thickness. Front door has a handle and it will have a lock. I'm not sure if I'm going to buy something from the hardware store or just 3D print anything, so I haven't put it in design yet. Back top area is where all the electronics are going to be located. I have an input power switch with a fuse, a receptacle so I can plug in a laptop charger as I'll be controlling this machine via laptop. Therefore there is also a USB port for serial communication, even though I will be able to connect the machine via Wi-Fi and store files directly in the machine. Inside is a power supply and a main controller board. It's a 6-pack Gerbil ESP32 CNC controller board, and it will need at least 2 modules. 0 to 10 volts output for controlling the spindle, an input module for limit switches, tool length probe and buttons. I added various plates and brackets to connect aluminum extrusions. In some cases it might be an overkill, but I don't think I can go wrong with more rigidity. In some cases I really had to consider the difficulty of assembly. Let's start with the frame. Wherever I could, I used double brackets or plates, and the rest was connected with a single slot bracket. Gantry is supported from the top, front and bottom. Gantry sides have a plate and brackets. And the bottom extrusions are connected with the L-shaped plates. But once I added Y-axis, I realized that at the bottom I have very little space to mount rubber feet. So I'm thinking of changing corner L plates to just a flat double plate, so I have space for anti-vibration rubber feet. For Y-axis, I just have many single brackets connecting all of the extrusions. The ones in the middle are mounted from the bottom, because if I need to service anything, once the X-axis is mounted, I would have easier access to them. X-axis is a combination of many parts. Ball screw will be attached to the middle, and on the sides I need space for guide blocks. That's why middle pieces all look different and unique. There are plates on each end and at the bottom, and the rest is with brackets. While reviewing, I just realized that for the plates in the middle, once they have bolts in them, bolt heads will stick out and interfere with the ball screw mountings, so I need to remove the plates and put brackets from the sides instead. The Z-axis is mounted from all sides with double brackets. This is just an initial design, so I'm willing to remove some brackets if they're really not necessary. Enclosure is mainly single brackets, but the front uses double because it will have the door hanging on. Next is to fix spotted mistakes, finalize plexiglass mountings, and a door to access the electronics in the back. I corrected previously mentioned errors. You can see the L brackets in the corners got replaced. Added anti-vibration rubber feed. Made the support piece for standoffs to keep the motor more rigid. I already 3D printed the piece and it's really strong, but I can make it even thicker if needed. For all acrylic walls, it's easiest to mount it all to the external parts of the enclosure, but in a way it will be blocking all access to extrusion profiles. So if we want to add something, it's going to be more difficult. I was also considering to put some soft flexible material like a cushion between acrylic and aluminum, so it seals better and maybe reduces the chance of vibration and noise. But if I need to add this angle support, it would interfere with the wall, so I would put the wall on the inside part, and it would also protect this extrusion from collecting dirt from milling, and I would have access to extrusion for mounting any external accessories. For example, this emergency stop or any other buttons to run the machine. That would be it for this video. I'm in the process for ordering all the components and preparing for the assembly. Thanks for watching.